Hello students, and in this lesson, we will be discussing about what is electronegativity, how it affects the formation of different bonds between different elements when they combine together, and I'll also be showing you the periodic trend of electronegativity and how it is arranged within the periodic table of elements. But before we proceed with our lesson discussion, let's have here a short pretest. Let's test your prior knowledge regarding electronegativity, and can you guess among these three set of pairs of elements on which of them is the more electronegative? By definition, electronegativity is the ability of an atom to attract shared electrons to itself. So basically, it's like an electron affinity because these atoms of different elements have the affinity for electrons because they love to fill their valence shell with electrons in order to fulfill the octet rule, thus making them stable. Now I have here an example of the sodium and chlorine atom. They're trying to form a bond, but what we call as ionic bond. But as you can see in the picture, the chlorine atom is having the power of grabbing more of the electrons than simply giving it away to sodium. And why is that so? It's because of their difference in electronegativity values. As I have shown here in our presentation, we have here a table of the Pauling electronegativity values, which shows the exact electronegativity value for each element. Now, this numbers is also shown in our modern periodic table, as you can see here in our carbon atom. That's the specific electronegative value for the carbon, and it's present in any periodic table that we have on our class. Now, when we talk about electronegativity, this has a specific trend as placed within the periodic table. Now, when we talk about electronegativity in the periodic table, it have its own periodic trend, which as shown here in our diagram, electronegativity trend increases as it go upwards and going to the eastward direction of our periodic table. So based from our diagram, we can say that the fluorine atom, which is in the most northeastern part of our periodic table, that is the most electronegative element, and the least electronegative element is the one located down right here on the southwest part of our periodic table. One thing about electronegativity is that it is a decisive factor in deciding what is the result bond that will be formed when different elements combine and form different compounds with each other. Now, I have here a video of a tug of war between fluorine and the carbon atom. So basically, electronegativity is just like a tug of war between elements. They have different electronegativity values, but the one with a stronger electronegativity will always win the war in pulling electrons. It's because they want more electrons for themselves rather than simply giving it or sharing with other elements. That's why, based on this video, it is guaranteed that the fluorine atom will be the one who's succeeding in this tug of war. You know why? Because it is more electronegative than the carbon atom, as shown in the periodic trend. Electronegativity is also the one responsible for the formation of the different polar regions between different compounds. Because basically, if two elements have a great difference between their electronegativity values, then of course, the stronger element will always pull out more of the electrons, creating a positive and negative polar regions between a compound. But if their electronegativity values are just close to each other, then that means that they are more likely have close in terms of power, and the distribution of electrons are just balanced or equal between them because they're not that much difference in their electronegativity values. Here are the answers for our pretest earlier to show you on which of these elements are more electronegative than the other. So I hope you learned something from this lesson, and I'll catch you on the next one.